Okay, class. So we ended our lesson on this slide. Now, this slide, I'm going to give you the answer. Please give it a try and check your answers. Now, a quick note, I'm giving you this Pascal's triangle. Now, this Pascal's triangle, it's all about how you can find the number, how you can use the numbers in Pascal's triangles to find the coefficient of binomial expansion. Now, we have a plus b to the power of n. So let's take a look. If it's power of 0, it's always 1. So we have 1. But a plus b to the power of 1, it's going to be 1, 1, using just the Pascal's triangle. Now, just looking at the Pascal's triangle, we're going to go on with the 1 on the boundaries. And then we have to add the two numbers to get 2. So what's 1 plus 2? 3. 2 plus 1? 3. And then 3 plus 1, 4. 3 plus 3, 6. 1 plus 3, 4. And then 1. So 1 plus 4 is 5, 4 plus 6, 10, 6, 4, 10, 4, 1, 5, and then 1. So that's what a Pascal's triangle looks like. However, now going to the binomial expansion, we have the power of 1. It's going to be a plus b. A plus b squared, we know that it's already a squared plus 2ab plus b squared, but it also maintains the Pascal's triangle. 1, 2, 1. 1, 2, 1. And then the next one, a plus b cubed, you have to memorize it, but it's easier to take a look at 1, 3, 3, 1. The coefficients, it's the same, 1, 3, 3, 1. Now the powers, look at the powers of, let's focus on a cubed 3, a squared 2, a 1, and then there's nothing, but you know that it's a to the power of 0, which is going to be 1. Now for the b, it's going to be the reverse. B to the power of 0, 1, it doesn't exist there. But here, b to the power of 1, b squared, and then b cubed. So it's reverse order for the second variable. It goes on for the fourth row and the fifth row. It's the same. All right, that's a quick note. This is going to be very beneficial. It's going to be very helpful as you solve binomial expansion. Now, one question. Use the Pascal's triangle to expand a, z plus 3 to the power of 4, and b, 2t minus 1 to the power of 5. Stop the video here. I'll give you the answer in 3, 2, 1. Here you go. Give it a try. Did you get it? Awesome. If you didn't, please ask questions. And here is the official homework for the first part of this lesson. Please give it a try. Now, we're not going to end here. Here comes your self-study time, but I'm here to help you guide the lesson, so please pay attention. Let's take a look at the second aspect. Apply 4 key factoring skills. GCF, greatest common factor, difference of squares, which is square minus square, a squared minus b squared. Trinomials, which are 3 terms, x squared, x, and then a constant, and then grouping. So let's start with this example question. Factor 6x cubed plus 3x squared minus 18x minus 9 completely. Use appropriate methods. If you look at this, do you know how to do it? If you do already, amazing. However, if this is something new to you, let's pay attention. So what's the very first thing that we need to do? Number 1, we have to identify what method we can use among the 4, GCF, difference of square, trinomials, or grouping. Now, is there a greatest common factor for the 4 terms? The answer is no. So we have to group the terms to grouping. Number 2, we group it into pairs. So we're going to rewrite subtraction as adding the opposites again, but we're going to group them into pairs. Third one, factor the common binomials and factor further of the remaining terms. Let's dive into it. 1 and 2. First, we identify the method, no overall greatest common factor, so we're going to group. So step 2, let's group them into pairs. Now, which 2 are we going to group? As you can see, we're going to group the first two terms and the last two terms because they have something in common. We have 6 and 3, so multiples of 3. 18 and 9, which are both negative, so we have negative 9. However, the first term we can factor out not just the coefficient 3, but how about x cubed and x squared? We can factor out the x squared. So we have 3x squared times the quantity 2x plus 1, and negative 9 times the quantity 2x plus 1. Okay, now let's factor the common binomials. As you can see, we have 2x plus 1 and 2x plus 1. So we can now further factor 2x plus 1. So what happens? We're going to group 3x squared minus 9, the first one, and then 2x plus 1 in the second one. So that's our factoring common binomials, step number 3. And can we go further on? Let's see. Yes, we can. 3x squared minus 9. Well, we can factor out the 3 out of the 3x squared minus 9. So 3 times x squared, and this would be minus 3 times 3. Hence, factor it out, we have 3 times the quantity 3x squared plus minus 3 times the quantity 2x plus 1. That is our final answer. Now, let's do this together. What is the greatest common factor of 6x squared minus 12x? And how can you do the difference of squares for x squared minus 16? So for the first one, 6x squared minus 12. Take note. Find the greatest common factor, which is 6x, and divide each term. So we're going to end up with 6x times x and 6x times minus 2. So we have 6x times x minus 2. The second one, why is this difference of square? Because 16 is not, oh, it is. It is a perfect square. You recognize a squared minus b squared pattern? So we have x squared minus 4 squared. So my a is x, b is 4. So we use a minus b, a plus b, x minus 4, x plus 4. Take note of this slide. How about this? Which two terms can we group? As you can see, the first two, we have x squared, and the last two, we have 4 as the common multiple. So take it out, x squared, and then x plus 2, and we have 4 times x plus 2. So now we have x plus 2 as a common binomial. So we have this. Now, going on, we have trinomial 3p to the power of 8 plus 15p to the power of 5 and 18p to the power of 2. Before we do anything, can we factor out something? Yes, we can. We have 3 in each one and p squared in each one. So take it out. So we have p to the power of 6 plus 5p cubed plus 6. Now we have 3 terms, trinomial. And how does it go from the first line to the second line? Disregarding the 3p squared, we have p6, which is p cubed squared. And then here, p cubed, it's already there. So p cubed squared plus 5p cubed. So it's squared plus 5 plus 6. So think of it as, let me write this down for you. All right, think of it as, let's do, all right, 3p squared. And instead of p to the power of 6, we have p to the power of 3 to the power of 2 plus 5p cubed plus 6. So in other words, we can rewrite this as, let's say p cubed is a variable a. So we can say this is a squared plus 5a plus 6. Now, can we factor a squared plus 5a plus 6? Yes, we can. It is a plus 3, a plus 2. So we have p cubed plus 3 and p cubed plus 2. So that's the reason why. Now it's your turn. Please stop the video here and give it a try. So checking your answers. Did you get it? Amazing. If you didn't, go back and take a look at what mistake you're making. And again, let's try to factor the polynomials completely for all numbers 4 to 9. It's your turn. And here's the answer. Here's the final homework assignment for factoring polynomials. This is again updated. Enjoy the weekend solving math. I know you can do it. Trust in yourself. Go back through the notes. I've given you all the required notes. Let's give it a try. You can do it. And prepare well for the quiz on Monday morning or for the last class Monday afternoon. Have a good weekend, guys. Bye-bye.